where you would have to build your own hash table, which means you would have to really know how it works. And that's the reason that we like Python. We like Python because we can get our solutions out faster than if we used another language that required us to do even more of the work.
I have a question, like when we use a dictionary in Python, so the language automatically do all the work in the back.
Exactly. You don't see any of how they do it. You just get your value back.
So which structure it choose to use since you give two examples?
You don't get to decide that. The people who wrote the Python programming language decide it, and they use a hash table that's more complicated than the one that than both of these solutions. Okay. But the point is you got to understand the simple one before you start even looking at a optimized complex version of it. And so there was a person on the Discord channel who actually started reading the code for the Python hash table. And I promise you, at least 80% of that is so the hash table interfaces with Python. It's not actually the hashing algorithm. And I think the Python hash table code was about 1,000 lines. But if you were doing this in C, you could probably do it in about 20 lines of C. So, a lot of that really was documentation and Python interfacing, not really the technique behind it. This also means that when you pass that key in, it gives you the hash to start your lookup, but because you never are 100% sure that that is the only element in that bucket, it also compares the key for equality against every value in the hash table. So it checks your key against the stored key, because it could have two keys stored in the same bucket, chain, whatever. Yes?
There's every key in that bucket.
Well, every key in that bucket chain till it finds one that matches or runs out.
You said it compares every key in the hash table.
I'm sorry. You're right. Every key in that very small subset of buckets inside that hash table, not against every key in the hash table. If it was every key against the hash table, it would be a list. All right. Thank you very much. Keeping me honest. All right. My mic cord prevents me from walking over there. Okay, so does anybody have any more questions about hash tables before we get into regular expressions? Awesome. If I get silence as an answer too many times, then I'll ask the reverse of the question and force you to participate. Pattern matching with regular expressions. Just so I can get an idea, who has heard of a regular expression before? Okay, that's about half of you. Who knows why it's called regular as opposed to, say, like a irregular or some other expression? A very small handful. Okay, it has something to do with computer science theory. This is not important to use them, for you to use regular expressions. But the reason that it's called regular is because it matches a very small pattern of languages called regular languages. The most important thing that you should remember about regular expressions and regular languages is that they do not understand how to count. So you can match just about anything you can, except that you cannot match something like this. Let's say I've got some sort of document that has a list of A, B, C, and D. Okay, and 0, 1, 2, and 3. And the way that I want to match it is I want to find from the beginning the letter C, and I want it to return from the 0 the same number off. Unfortunately, due to the way that regular expressions, the part that makes them regular, is that there is no trick that I can pull off that will avoid having to count. I will have to count that this is the third one here, and this is the third one based off of the 0. Okay, because like if I had A, C, D, E, 0, 8, 9, 11, then here, that C would only be the second one off, and I would have to shift the 8th. This kind of pattern cannot be described using a regular language. So that's the regular part of regular expressions. And if you're really interested, I can point you to more resources after the class. But all I want you to do is never try to count with a regular expression, because you will find out very quickly it doesn't work. All right, now there's several tricks we can use though that don't actually require counting, and we'll cover those as we go on. So the whole point of a regular expression is you write in some sort of a language that happens not to be Python, but happens to be very popular in computer science, called regex, of matching pattern. And then it will take an input, or any number of inputs, and come back and say whether or not it matched. And there are other techniques we can use that will allow us to not just match things, but also to capture parts of the patterns so we can reference them later. It'd be very useful if, like, you're trying to pull something out of a letter that maybe is a salutation. It has a particular pattern to it. You can't be sure that it's the salutation, but you can write a pattern that probably would match it, and maybe you could then like use that in order to speed up your pattern matching. So regular expressions specify a pattern of text that you're searching, okay? And in this case, the pattern that we'll be discussing today is the ever ubiquitous 10-digit phone number, okay? It makes a really good example for regular expressions. So this is a 10-digit phone number, and this is a 10-digit not phone number. And so it's not about the number of digits, and it's not about the value. It has to do with the way the text is arranged. Phone numbers typically have hyphens between their sections of digits. Now I understand that I'm actually standing in a state where we've got parentheses around this first triplet. But the point is that for the purposes of this book and to stay consistent with the material, we're just going to use a hyphen. And then over here, this obviously has no hyphens and has commas. And so if you told somebody, you know, what's your phone number? And I said, oh, you know, it's 8,320 something thousand, blah, 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 I'd probably lose them. But if I said 832 and then pause, then they would know exactly how to call me up. Again, if you're not a programmer, you probably never even thought about regular expressions, but you may have used something very similar. Who here has used the command line prompt on DOS? It's got a pattern matching thing in there, right? You type in star and it matches whatever. This is not actually a regular expression, but it is a similar language. This is called the glob language, and it matches in ways that the regular expression language can match too. The reason why regular expressions are used more by programmers is because you have more control over the matching. So you can specify patterns with higher resolution to match data more precisely. Glob works very well. It's just glob doesn't often provide you with this kind of specificity. So here's a nice little quote by Cory Doctorow, saying that knowing regular expressions can mean the difference between solving a problem in 3 steps and solving it in 3,000 steps. Okay? And then he goes on, if you're a nerd, and blah, blah, blah. But the point is that it's true. Regular expressions simplify the amount of work that you do because you're using a language and you're forcing the computer to do the matching for you. We'll go through and show an example of how something that should be very simple to do in regular expressions can actually be very complex without them. So when you start programming, usually you start by looking for patterns without regular expressions. Who can remember how to find a character in a string? Okay, good. You use which function?
Use index.
Very good. You use index. All right? And you can break the string up into pieces using substring afterwards and check the contents of each one of the chunks after you index the separators, right? I mean, it's not something that you may have done yet, but the point is this technique is available to you. And writing all those indexes and writing all of those substrings and doing the processing on each part can be automated. And regular expressions automates that kind of searching pattern. So let's take a look at how we would do it the hard way, using index. So here is our phone number matcher. We have this function, is phone number. Can people in the back see this? Yes. I did not start the recording on my screen. Do you want me to?
Yes.
Okay. So this is the is phone number. All this is going to do is tell us whether the string that's passed in as text matches our expectations for what a good formatted phone number is. First thing is that a phone number, the way that we defined it, has 10 digits, but it also has 2 hyphens. So if the length is not 12, we immediately bail out, saying there's no way this could be a phone number. It's lacking the correct pattern. Then what we do is we count off the first 3 digits and say, if that digit is not a decimal. Now, who can remember what is decimal checks? Go for it.
I think it's if it has no non-number components.
That's a very technical way of saying it. You're absolutely right. Let me say it in sort of more a modern parlance. It consists of the digits 0 through 9.
In the good old days, those were always names. Garden 3.45.
Well, we're not talking about real phone numbers. We're talking about the example here, because we don't even have the parentheses. But I know exactly what you're talking about, and it makes for a lot of fun when you watch an old enough movie where they ask you for, like, Harrisburg 329 or whatever. So the point is that if the first 3 characters are not recognized as the numbers 0 through 9, then it'll say, no, this is not a phone number, and it'll exit before it even gets to the next check. The next check is if the 4th character, remember, this was not inclusive. This one is exactly character 3, which would be the 4th character. If it's a hyphen, if it's not a hyphen, then it doesn't have the hyphen in the right spot. It's not a phone number. Again, we're going to start off with the next 3 characters. 4, 5, and 6, but not including 7, and say, are those decimals? If they're not, it's not a phone number. Then we'll say, is the character, the 8th one, but at index 7, is it a hyphen? If it's not a phone number. And then finally, we'll finish off the phone number and say, are the last 3 characters, the last 4 characters decimal? And if they're not, then we'll say it's not a phone number. But if we manage to get through all these checks, now keep in mind, we have checked every character in this 12-character string and checked that it is a 12-character string. So if we get down here, it has passed every one of our tests. And we will say that it is a phone number. Okay. Who can see the potential for problems in a routine like this? I want one opinion.
It's very rigid.
Yeah,
Is it
it's
somebody's
rigid.
parentheses or something?
It's rigid, but computers are rigid. Pretend for a moment that I had made a mistake. Is it simple in a routine that I have to scroll up and down on to make sure that I have not forgotten a single important case or not done a single typo where I did a not equals when I meant to do an equals, or an equals where I meant to do a not equals?
What if it's not a number, not a phone number, even though it conforms?
Well, hopefully it would hit one of these return falses and report back that it is not a
But
phone
if
number.
it passed all of them, it could still not be a phone number, right? There could be no such phone number.
We're only concerned with the format. We're not concerned with the validity of the phone number. Valid phone numbers, you would have to contact the telephone
yeah.
company in order
I
to
see.
see if it's active. Okay? So the point is that there is some chance that I used the wrong range somewhere here and didn't check every digit.
Edwin doesn't make mistakes. That's not going to
Oh, if only I were not human. I do make mistakes, my friend. I'm so sorry to ruin that misconception. So here we go. And this is an example. Here we're going to say, print that as a phone number, and now we're going to basically use our function, which also should return back its a phone number. And then we're going to say Moshi Moshi is a phone number, and is phone number Moshi Moshi should print back false. So here we go. This is a phone number, true. Moshi Moshi is a phone number, false. And Moshi Moshi, I just happen to know, is how most Japanese people greet themselves on the telephone, or greet others on the telephone. So the is phone number function has code that does several checks. We went through all the checks. There's quite a few of them, actually, in order to see whether or not the input fits the format of a phone number. And all it does is it reports back that it fits the the format. It doesn't report back that you can actually use it or that there's an area code that exists there or anything like that. Okay? And it does it, and we'll skip over how it does it because we described it while we had the code up on the screen. So calling it with this argument will eventually pass all those checks and get to that bottom where it returns true. Whereas calling it with this argument will return false because it'll die on that first character check. The letter capital M is not a digit. Okay? Oh, actually it'll die even before then. I didn't read the whole thing. Moshi Moshi isn't 12 characters long, so we'll die even before we check the letter M. Okay? So, now, let's say that we've got actually a larger string here. Call me at this phone number tomorrow. That phone number is my office. Then what we have to do is we have to start basically going through this string, looking for 12-character phone numbers. And if we want to reuse our code the way that it was written, then what we would actually do is go through each 12-character string, which there's smarter ways of doing it, but that would reuse the code the way it was written and perform almost that many checks. One for each one of the characters highlighted, because somewhere down here you finally get 12 characters and so it won't do the last few. When it's ran, it will eventually find both phone numbers. But it started off by trying to check, call me at something. And then it did the next check, which was, all me at something with one more character. And so on and so forth. And this is a very, very wasteful way of checking phone numbers inside a string. Because you're basically taking this string and converting it into, in this range, basically one string for every character, and then checking that string. This is where you construct the new string, This is where you're doing it once for each character. So there's several ways we could have fixed this. One way was, if we saw that it wasn't a digit, we could just keep skipping instead of building the whole string. But the point is we're starting to write a lot of code to check for a pattern. Now sometimes this is appropriate, but this isn't the point of this chapter. The point of this chapter is how to do things quickly, easily, using Python. And Python comes with a regular expression engine, and that is what we're going to learn. The regular expression engine writes the code that would do these checks for you, and writes it in a very efficient, fast way. So it's worthwhile for you to learn the regular expression language so you can use that engine and avoid writing these checks yourself. And now they're describing how you would go through the block of code above, and we just did. Does anybody misunderstand how we would go through the block of code above? No? Then I'll spare you the word-by-word recap. So how do we find text with regular expressions? Well, there's a couple of problems that we didn't even account for in our isPhoneNumber function. First off, it's 17 lines long, but only finds one pattern of phone numbers. We may want to support phone numbers that look like that. Notice that this phone number actually has 13 characters because it's got a space in there too. We might even want to be able to find phone numbers that have extensions. Writing all of these different scenarios in there, it's going to get a lot larger than 17 lines really fast. So, regexes are descriptions of patterns of text. And so what we'll do is we will use a description of a pattern, and then we will say, does it match this pattern? In regex, there's a special character. I shouldn't call it a special character. There's a special sequence of characters. A \D. \D in a regex means something. It means digit. So it will match 0 through 9. So that entire 17 character long matching pattern can be written like this. \D, \D, hyphen, 3 more \Ds, a hyphen, and then 4 more \Ds. Okay? Whereas other strings that don't fit this pattern won't match it. You'll get basically the false that we would have had in our isPhoneNumber. Okay? So, if, for example, we had a number that had 2 numbers, a string that had 2 numbers and then a hyphen, then this third \D will not match. Now, there are ways of making it even easier to write a regular expression. And so Python uses a very popular extension notation, which is curly brace 3. Curly brace 3 means 3 of the thing right in front of it. So this \D curly brace 3 is exactly the same as 3 \Ds. So now we can even write our regular expressions smaller. And it's easier to rationalize about this pattern because you get it all right in front of your eyes, not across 17 lines, and hopefully, since it's all right in front of you, you should be able to see whether or not there is a mistake in the pattern that you're asking for. Okay, so the pizza just came. Who wants to take a break and get some pizza?
While it's hot.
All right, there, let's get some pizza while it's hot, and then we'll talk about how to actually start programming with regular expressions instead of just describing them. idea behind it, even if you can't remember the details, often if you remember enough of the ideas, you can actually find the detail that you needed. So we're going to create a regex object. And it all starts off with import RE. Now, for some reason, they decided that regex is the best way to abbreviate them because, obviously typing regex is 4 more characters than possibly you need to, is to type RE. So if you ever attempt to use a regex and you get some sort of name error, RE is not defined, it's because you forgot to import RE. Now, we've done imports before. Most famously, sometimes you'll see us import math. Other times we'll import other things. But the point is that this imported, there's nothing special about it. It's what we're importing. We're importing the regex routines. Okay? And the reason that we need these regex routines is because we are going to use recompile at some stage. And compile takes that pattern and churns it into all of those checks that we normally would have had to write ourselves and perhaps even include extra bugs ourselves. So when you compile using recompile, you create an object, and that object has a type of regex. That means that here, when we recompile this regular expression, now I will discuss what the R is in a minute. But for right now, this is the string of the regular expression. And when we recompile it, it's going to return back an object that can be used to match strings. And that object will be stored in this phone num regex name. Okay? Now, since I said I'd cover this R before this string, you'll probably recall from Evan's talk that when we type a backslash like that, that's a new line. And if we want to type a backslash, we actually have to type backslash backslash, 2 backslashes, and then that will collapse down to 1 backslash in the string. This collapsed down to a tab character. This collapsed down to a new line. Well, when I said that that pattern backslash D is a regex notation for a digit, that was not an escaped D. That was a backslash D in the string. So to type this backslash D, I would have to actually escape the backslash so my string wouldn't think I'm trying to do some sort of weird funky thing with the letter D. And so this would turn into backslash D in the string. Okay? Typing all these extra backslashes is apparently just too much for computer people, which is if you prefix your string with an R, then it will assume that the backslash. So some people like to think of this R as regex. Really, it's not, because as Evan mentioned before, it's raw string. Okay, but the point is that this means that we don't have to type backslash backslash D. We can just type backslash D. So now that we've covered that, here's our pattern string. We compile it. It creates a regex object, which is returned back and stored into phone num regex. Okay. This is all of that fancy stuff we just talked about the backslash backslash, so I'll skip that. And this is where they basically say that is much easier than typing this. Okay. So matching regex objects. Once you get a regex object, you can basically use the search method on it to search a string for a matching pattern. So here, we compiled this phone number matcher that we've been talking about so far. And here, we use the regex object and search this string. And hopefully it'll match this. And sure enough, when we get the result passed back, which is a match object, it's not the regex engine, it's the possible match that's returned. When we say, hey, give us our groups of matches, then it will return back the text in the input that matched the pattern. So I'm going to say it one more time because sometimes repeating helps. You compile patterns which give you regex objects, which you can then use to search input, which then give you back matching objects, which then you can pull out the details of what matched. This pattern of using the pattern to make a regex object, the regex object to search input, and then the input returning back a matching group, matching object of some sort that has the details of where it matched. This pattern will be used over and over in regex, so get very used to it. Compiling a pattern is expensive, but patterns can be reused. I can just call this num regex search with a different input and reuse it. I will get a different result back for each time I call it. But when you have a large number of things to match, you don't have to build the same number of patterns. You can just build one pattern for each thing you're looking for.
Excuse me.
Yes?
Is that the plus and the other, that's part of the code too, like plus before mode?
So this MO, I'm calling it a matching object because it contains the information for where this pattern matched this input. This calling MO group returns back this part of the string. The plus here is to join it to this part of the string up here. And then that way when we print it, we get this whole string back. Okay, so the plus is not actually part of the regex thing. It's just how we are combining the strings. All right. So they're talking about MO variable, which is just what they used to call match. And match is a type, objects. All right. So it may seem complicated at first, but not if you just had me explain it 3 times. So is anybody unclear on that? Because that pattern of compiling and then searching and then pulling out the results, that will be all of your use of regex forever. So are we clear on that? General approach? Awesome. Then let's move on, and let's move on quickly. So that's just going through and talking about what we just talked about. And a review. Import the regular expression library, or the regular expression module as it's called in Python. Compile your pattern, creating a regex object. Search your input with that regex object, which returns back a match object. Call methods on that match object, which the only one we've talked about so far is group, in order to get the actual matched text. Now, grouping. Occasionally you'll have a pattern, but you don't want just the matched text. You want to be able to say, oh, I want to be able to handle like the first part of this separate from the second part. So the first part in our phone number example will be the area code part, and the second part will be the rest of the phone number part. And so what we're going to do is we're going to use group and parentheses to basically be able to capture pieces of the pattern as we want. So here, you'll notice that we have these parentheses inside this regex pattern. These are not the same parentheses you know. This will not actually match the parentheses. this will group regions of the regex language. So this first parenthesis, we're not matching to see if it starts with an open parenthesis. What we're doing is we're telling the regex engine that the 3 digits comprise of a group that it should store in a way that we can pull it out later. And this parenthesis after the first hyphen, again, is not part of the text. It's part of the language that says, until we hit that end parenthesis, the rest of this should go into another group that we can pull out later. How do we pull out the actual individual groups? Well, you pass a parameter to the group function. So group 1 indicates we're pulling out the one group, the first offset. Okay, the first index, I should say. And group 2 means we're pulling out the second group. And group 0, well, then we're pulling out the entire pattern, which is exactly the same as calling it without a grouping number. So as you count these left to right, that will determine what index inside the group you might need to pull out. So if I passed in a different phone number, say my phone number, which starts with 832, and I called group 1, then I would get 832 on the match object that was returned back from this search call. Okay. There is a groups, notice the plural, and what that will do is that will return back a tuple of all of the matched items in order. Now it doesn't actually return back, for some reason, the entire string match. It just returns back only the groups that are inside parentheses. And because it's returning it back in a tuple, we can use the multiple assignment technique and capture both of those into 2 different variables in one call. Do you remember how this works? Okay. Do you not remember how this works? I got the same response both times. So we'll cover it again. Groups, by returning back all of the groups, is going to return back this compound value. And the first item in this value will get assigned to the first variable in the assignment, whereas the second item will get assigned to the second variable. And this will happen all simultaneously on this line, such that when we print the area code, we get the 415, and when we print the main number, we get the rest of the number. Okay. Did the pizza put you to sleep, or is it just the regexes? It was not a question I really wanted the answer to. So here we are, and we're using basically the multiple assignment approach in order to capture the groups. And of course, our multiple assignment has to match the groups that we declared in the pattern. If we multiply assign groups that aren't inside the pattern, you will not get the results that you expect. Now notice here that something's a little bit different. We're using this R, so that means that all of our single slashes are actually double slashes. Okay? And you'll notice that here we've got a nice parenthesis. That should give us a hint that we're doing a group. But here we have a backslash parenthesis. There we go. I finally got it. A backslash parenthesis. Knowing what you know about the techniques of backslash things, would you expect this to be the start of a second group, or would you expect it to be something else? Okay, I heard 2 answers, and they were both good answers, but only one of them, unfortunately, is right. I heard second group, and I heard a literal parenthesis. When you do backslash things, it usually indicates that the next character is special. And even though we did backslash n and backslash t that don't map out to n and t, they map out to new line and tab, we do kind of have a precedent of backslash backslash mapping out to backslash. In regex, if you're using something that could be special, like a parenthesis, sometimes you really do need to match the character parenthesis. And so the way that you let the regex engine know that this is just a character parenthesis and not the beginning of a group is you put a backslash in front of it. Likewise, this end backslash indicates that this ending parenthesis is just a regular character. Yes?
How come the R doesn't work for those and it only does it for the D? Like the raw string that we put in front?
Mm-hmm.
How come it doesn't work for the parentheses and it only works for the D's?
So all the raw string is doing is saying, I know it's going to be really exciting, especially after eating some food. So like this phone num regex, that's something that means something in the Python language. As does the equal sign, the RE, the compile. This parenthesis is something that means something in the Python language. This R means something in the Python language, and this quote means something in the Python language. But the stuff between these quotes, that's not Python language. That's regular expression language. And so in regular expression language, a parenthesis indicates a group of things. That means we have no way to actually match an area code like this unless we have a special way of indicating this parenthesis is just a parenthesis. It's not the beginning of a group. And so in the regular expression language, we see it's not a group. So that means that inside this group, we have 5 characters. A parenthesis, a digit, a digit, a digit, and a closed parenthesis. That will permit it to match this, including its parentheses. These parentheses that flank that series I just talked about, these parentheses are the grouping parentheses that will allow us to pull this value out as the first group. Okay? If it's still unclear, that's fine. But if it's still unclear, I'd like to hear what's confusing.
So you say the print out, the first group, it has that parentheses, right? It's the
Character parentheses.
The outside ones, not
The inside one, it's clear? Awesome. So now when we print out group 1, we get 415 with the parentheses. Okay? And of course, because we didn't do anything special with adding extra characters in our second group is the same. Now, it is possible to define your own groups in Python, but these types of groups are not capture groups. Before we talked about a kind of group that we usually refer to as a capture group, which is a way of taking the text and chunking it down to where you can pull out many values off of one match. There is something inside the regular expression language, which is called a group, which basically is sort of like an this or that type sort of statement. So right here we have a pattern, and we are going to say we want to match Batman or Tina Fey. Okay? Because everybody knows that these two things go together. The point is that in order to separate those two groups, we are going to use a special character that's on everybody's keyboard, but very few people use it in normal correspondence. It's called the pipe. And the pipe sort of looks like an L, except it's not an L. It's taller, it's longer, and it's skinnier. And if you take a look right above your enter key on your keyboard, you will see that there is a pipe. It's the shift backslash on most US keyboards. So here we are saying we're building a regular expression that will either match Batman or match Tina Fey. And so here when we search it, it will match with Batman and Tina Fey. And then we ask for its group, it is going to say Batman. Now there's a reason why it doesn't come back with both. Okay, we'll cover that. If we reversed it, it will come back with Tina Fey and not pick up the Batman. And the reason why is because what will happen is this group will only report the first match. If we want to report all matches, we've got to use a different method on the regular expression object, the regex object, called findAll. So here, if we use findAll, then basically, apparently we're going to discuss that a little bit later, but basically what it'll do is it will return back a list of matches. And we can go through each individual match, and in that case, we would find Batman and Tina Fey in whatever order we put them in that input stream. Now let's say that we want to have a regular expression that matches most of the Bat objects, which includes Batman, Batmobiles, Batcopters, and Batbats. Well, we can use the grouping operator in conjunction with the regex group and basically indicate that inside this capture group, we're happy to capture man, mobile, copter, or bat. But it does need to begin with a bat. And so that means that this bat will match here, and then this capture group will say, oh yes, that is a mobile, and capture that. And so this entire word here, Batmobile, will successfully match this, as will Batcopter just landed, or Batman has left the building. So here, when we ask for the entire match, we get the group, Batmobile. And then if we wanted to figure out what that capture group matched, we could ask, what was the first capture group's match? And it would be mobile, or mobile, depending upon where you're from. So the concept is that you can match things with fixed prefixes that have many different possible little suffixes by using a capture group and using a fixed prefix. Likewise, you could match multiple prefixes with a single suffix using the same technique, just basically putting the fixed string at the end of a capture group. So every time you need to match, where you could maybe match 2 or more items that you wanted to swap out, you use that pipe symbol, which again leads us to the question of, what if you want to match the pipe symbol that's actually in a string? Very good, exactly. You would use the pattern \pipe, which almost looks like ASCII art, but the point is that you're escaping the pipe, so the regex engine knows that you're not talking about a substitution here. You're talking about an actual pipe character. Okay, optional matching. Regex has a few other special characters. We're going to go through them. The first thing that we'll cover is something called optional matching. And optional matching is done with a question mark. And a question mark basically indicates that you have the ability to match what's ever in front of it. In this case, whatever's in front of it is a group of 2 letters. So this would match bat, possibly a WO, and then man. This is a way that we can get both genders of bat people. We could have bat man, in which case this WO group didn't capture anything, which will be fine because we specified it's optional. Or we could match bat woman because this WO group would capture something and it's optional. In this case, it just happens to be there. There's another way of writing this. And with a lot of languages, you wind up with multiple ways of expressing the same thing. Regex is no different. Somebody may decide to write it like this. This works. For various reasons that we won't go into, this is less efficient. Because what happens is, in order to find out whether I match, I have to back up, back to the beginning as soon as it stops matching one of the options, and scan the other option down from the beginning. This approach matches the bat very tightly before it possibly checks to see if there's a W or an O. So sometimes if you get regular expressions that are really big, it might be useful to look at about how they actually go through the mechanics of matching so you can write faster regular expressions. But the point of writing regular expressions is not to write the fastest regular expression. The point of writing regular expressions is to have this language at your command that makes it easy to match things. So here, this would match the Adventures of Batman because the WO group would not be matched, which is just fine because it's marked as optional. And where here, we will use the same regex object. It will match the Adventures of Batwoman because the WO group is just fine because while it's optional, it also can be present. All right. So now we're going to expand our phone number pattern matching thing to permit phone numbers without an area code. So we put those first 3 digits in the first hyphen in a group, and we say that that group is optional. Very good. So here, it matched it with the regular phone number, and here it matched it without the area code prefix. In this case, if we called group 1, we would get 415 hyphen, and in this case, if we called group 1, we would get the empty string, the string of no characters. So you can always think of the question mark as saying match 0 or 1 of the thing in front of it. Now, what if we don't know how many of them there are, but we would like to match them anyway? That's what the asterisk is for. Often referred to as the star, or that little funny thing that you use to multiply on computer keyboards. The point is that this asterisk means 0 or more. So this is the same pattern, but with the optional replaced with the asterisk. So it's not going to be 0 or 1, it'll be 0 or more. So this will match Batman, Batwoman, and Batwowoman, and Batwowowowowowowowowoman, and any other combinations of numbers of woes that you could want to put in there. And so here it is matching Batman, here it is Batwoman, and Batwowowowowowowowoman. And for Batman, the woe part of the regex, we just covered it. It matches 0 or more copies of woe. Now, it won't match Batwowman, because that would be W-O-W, and it would be missing an O. So it could not appropriately expand this group. It will always be pairs of W's and O's. So who is unclear on the asterisk? Who's unclear on the question mark? We're running out of characters in regex. That's a good thing. Now, sometimes you want to match one or more. When you want to match one or more, as a convenience, they have included a plus. And so plus means that there must be at least one, but there may be more. So this will match bat woman, and this will match the bat woman. But it will not match Batman, because the plus designator indicates at least one copy of the thing before has to match. All right. If counting off those groups of woes wasn't enough, there is a way that you can actually specify an exact number of woes. So in this case, we're going to shift over to laughing, ha, and ha in a group with these curly brace 3 close curly brace specifies this is a special regex construct that indicates exactly 3 of the thing in front of it. So this ha will not match ha ha, but it will match ha ha ha. And again, because you might want to match some sort of range of number of ha's, you can also extend this to 3, 5, or some number, comma, some other number, and it will match any number of ha's between those two items. So this will match 3 ha's, 4 ha's, and 5 ha's, but it will not match 6, nor will it match 2 or none. And you can leave off one of those 2 ranges, in which case 3, comma will match 3 or more, and comma 5 will match up to 5. Now, up to 5 also includes 0. So this is not a straightforward replacement if you needed 1 ha. You would have to specify 1, comma 5. So here we go. Ha 3 is the same as ha ha ha. Ha 3, 5 is the same as this regular expression here. Oh my gosh, look at the number of groups on that. I bet you would really love to dereference every one of those groups. I know I would, and we will do that now. No, I'm just kidding. So here we go. We've found an even faster way of typing ha ha ha, which is the group ha matched 3 times. Searching that, it comes back. Great. Using that same pattern, matching it, it comes back. No, there is no match object that's valid for it. And now we get into greedy and non-greedy matching. So there's a question that we just kind of glossed over because we're learning this and you don't know how to ask or didn't bother to interrupt me, I'm not sure which, the truly hard questions, which is if we have ha, 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 and we're matching ha between 3 and 5 occurrences, why didn't it stop as soon as it found a valid patch? Because, I mean, ha 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 would have been a valid match. So why did it match all the way up to 5? Who cares to guess? Who read ahead? Okay, you read ahead.
Just greedy matches as much as possible.
That's right. Every regular expression in Python will, unless you configure it to do otherwise, greedily match, which means it will try to expand out to the largest possible match that it can. Okay? that means that some interesting things that we'll get to when we cover the dot match. Okay? So yes, it will match out to all 5 if possible. So here we are. Here's our 5 Ha example, and sure enough, it matches to all 5. Now, how do we specify that we don't want to match greedily? Well, in this case, and I don't like reusing a character for 2 meanings, but in this case, we reuse the question mark. And the question mark means that rather than greedily match the pattern, we are going to do a non-greedy match. The very first moment in time we can say the pattern matched, we're done. So this 3, 5 with the question mark at the end, all of this is just a specifier to say how we're going to match this Ha. We're going to match it between 3 and 5, and as soon as we find an answer, we're done. We don't keep matching. This is roughly the same in this scenario as writing this pattern. Because it'll match the 3 Ha's first, and then it won't continue on. So here, when we print out this group, we're getting the first 3 Ha's on our ha 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 string, and so on. Now, greedy and non-greedy matching is easy to talk about. You'll find with experience using regexes that sometimes you won't get the results that you expected, and then you will realize, oh, it's because I wanted a non-greedy match. It's important for you to understand the non-greedy matches but the non-greedy operators. So is find all. Now, they kind of alluded it to the beginning and I gave away the punchline, but find all basically applies the regex to the string, but instead of returning back the match object, which is the first match, it returns back every possible match that can be found in the string. And so here, if we just use this regex, our famous phone number regex, it'll come back with this nice little match right here. But if we use the find all, then it comes back with a list of matches. Okay? Does everybody see how it took the same pattern and just kept applying it anywhere they could find a match? Is this something we can gloss over or something we cover in depth?
Does it matter that they use the list, whereas they use the tuple when they were doing the finding the parts?
So you don't really have control over what the functions return back. So the only thing that matters is that you're prepared for what it returns back, because you can't actually influence to do something else. Okay? But in this case, this find all is going to return back a list. The one that returned back the tuple was when we used the groups operator. Yeah. But find all, it found the first match here, and then it found a second match there, and if we had more phone numbers, it would find more matches as long as the pattern matched. So when we have groups, and we use groups in conjunction with find all, then what will happen is we will get back a list of matches, but the matches themselves will contain tuples of the groups. So I guess it's kind of the best of both worlds, or the worst if it's not what you really wanted. But the point is that this is what it will return back, and this is what you should be prepared to process. Okay. So when it's in a regex with no groups, it returns back a list of matches. And when it's a regex with groups, it returns back a list of tuples. And the tuples themselves contain each group that matched in order. And finally, we're getting down to some of the interesting bits that we haven't covered before. Characters. So far, all we've been matching is digits and hyphens, okay, and the occasional parenthesis with an illusion that we could possibly match a pipe if we actually had one of those as an example. A character class is a group, but it's a group consisting of just basically characters. So this \D, it's shorthand for a regular expression like this. You could have written the regular expression, match a 0 or a 1 or a 2 or a 3 all the way up to 9. It's a lot of typing, all right? It's a chance to make a mistake, and generally speaking, when regexes came out, everybody was really interested in conserving typing. So, we didn't force people to do this as soon as we could all agree that \D would replace this for us. But the point is \D is a character class. It is a character that talks about an entire group of characters. There are other character classes. They decided not to use some sort of weird not operator, whether that's a tilde or an exclamation point or the word not. Instead, they decided to use uppercase. So this \D matches any digit 0 through 9. And the uppercase \D matches anything that's not one of those digits. Likewise, this W matches most of the characters that consist of words. A letter, numeric digits, underscore characters, it's a whole chunk of things. It doesn't include spaces though. Doesn't include tabs. Doesn't include new lines. So you can often use \W to match an entire word, a word in this case being a continuous typed thing of characters surrounded by spaces or something. This \W is anything that's not a letter, digit, or an underscore character. You can pick up punctuation, commas, white space, new lines. /S, any space, tab, or new line character. It's supposed to be like the white space characters. Anything that's kind of putting a little bit of space in between your possible words. And \S is any character that is not a space, tab, or new line. Now, I know that I have represented these as sort of like mutually exclusive. \W almost sounds like characters that fit in between it, saying always match something. So character classes are nice when we need to shorten things. But there is also character classes that we can construct using square brackets. And square brackets is a special way of putting into the regex notation a range. And so if we use this square bracket, it will start at one character. The hyphen will indicate all the way up to, and it will end on another character. Now, you have to know what order the characters are in. Otherwise, this range operator might not do what you think. For example, if you say capital A through little z, you will certainly pick up more than just letters. Okay? But the point is that you can use an ASCII table or some sort of other character set table to look at the characters and see which one starts and which one ends and pick the appropriate range. So this square bracket 0 for 5 is again a character class, which is shorthand for 0 through 5. Now you'll remember that in Python, a lot of the ranges don't include the ending element. And you'll remember that I have said a few times that the regex language is not the Python language. It is a different language. The ending character in a regex range is included. So 0-1 would match both zeros and ones if it was inside a pair of square brackets. So here we are, and now what we're going to do is we're going to compile another pattern. Who wants to hazard a guess at reading this pattern in English? And by in English, I do not mean \D plus. I mean try to describe what you think it might match. Marco.
One or more digit followed by one space character, followed by one or more white space character. I can't remember SW.
Space is, I didn't repeat yet 3 times. Maybe that hasn't been drilled in. So now we're going to match it against this. And sure enough, it comes back with a nice set. It comes back with 12 drummers, because that is 2 digits, 1 space, and 1 word. 11 pipers, 10 lords, okay? When it gets to 9 ladies, it's still 1 or more digits. So it's still going to match, okay? And so on and so forth. Now, if you got down to 1 partridge in a pear tree, I would expect it to only match the 1 partridge, because this pattern does not expand out to include the white space afterwards, and so it would not also grab the in a pear tree characters afterwards. Okay, making your own character classes. Well, we talked about how to do it with the range operator, that little minus sign. 0 through 5 was the example. But you don't have to specify a range. You can just start typing in whatever characters you want here. And what will happen is it will say that this is a character class that consists of the characters that are inside these square brackets. Now, there are limitations. Who can guess a character that I can type in there that'll probably mess it up?
Square bracket.
A square bracket. Awesome. Because a square bracket will probably stop the range. It doesn't really matter which one you use either. It'll probably stop the range. So the point is that you can basically do this, and this would be like a nice vowel range, A, E, I, O, and U. Okay? Apparently the sometimes Y does not apply in this case, and we're going to match RoboCop eats baby food. Baby food! And we get back all the vowels in there. Ooh, 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 E, ah, ah, ooh, ooh, ah, oh, oh. In which case, mission accomplished. But we can also use this more sophisticatedly and say we want to match all the lowercase letters, all the uppercase letters, and all the digits 0 through 9. Now, when this hand-constructed character class matches, how many letters or numbers will it match? Marco. Not Marco.
Marco.
Yeah, I already got Marco. I got to get somebody else. You. There you go. How many will this match?
I don't know anything about Python.
You only filmed this thing? Oh, that's horrible.
It's bad.
Jared, how many characters will this character class match?
All the lowercase letters, all the uppercase letters, and 0 through 9.
Yes, but how many if I were to count them? 62 is a very good answer. Unfortunately, it is wrong. Because we did not specify a control character after that indicates that it will match any more than 1. There is no question mark making it optional. There is no plus sign indicating 1 or more. And there is no asterisk indicating 0 or more. So while there are 62 possibilities that would match this character class, the entire character class will only match one character.
Or 0.
If it matches 0, since it's not optional, it won't match correctly. You'll actually just get back that there was no match. Okay, so there we go.
Before we move off that, just one passing comment.
Sure.
Whenever possible, you should use the built-in character classes like alpha or alpha num, because when you do it like that, it actually depends on what locale you're using.
This is true. It's not aware of what language. So like if you think, oh, I'll write it with like this, A through Z, 0 through 9. There are plenty of languages that don't just have the characters A through Z in upper and lowercase. Very famously, the old Spanish character sets have ñ and ly. Okay. French character sets have all sorts of wonderful things that I don't even know what the names of are, and probably couldn't pronounce them even if I did. And so on and so forth. So you're correct. Like \W pretty much encompasses all of what I typed here in any language. Whereas this, it might not even encompass all of what I typed here in English if I happened to use an accented character that does not fit between little a and big Z.
In my recent experience, they've even recently changed it where like the order is uppercase A, lowercase a, uppercase B, lowercase b, and so those ranges don't actually, do what it looks like they do.
Right. And so, like, if there is a range that's already built in, by all means, use the built-in range. The main concept here is that we're trying to show how you can build your own character class. And sometimes this is useful. And sometimes it's less useful. But the point is when you build your own character class, you can also use the range operator inside your own constructed character class. This is not a good way of matching all the letters and digits, but this is a good example of showing how you can use the range multiple times when constructing your own character class. So thank you very much, because that's a good point. You don't want to actually use this example if you can avoid it. All right. So inside the square brackets, normal regular expression symbols are not interpreted as such. So that means that you can actually type a period, and it means period, a star, and it means star, a question mark, or parenthesis characters in there, and it will basically work the way that you would not expect it to work if that character was outside of these square brackets. This right here will match a digit 0 through 5 or a period. We didn't cover periods, did we? Not yet. I think it's down lower. Anyway, the point is that you wouldn't have to escape the period. If we did this same example with an asterisk, we wouldn't have to escape the asterisk, or a question mark, or a plus sign, or whatever. So here we're compiling our regular expression, and what we're doing here is we're talking about a special character, which is called the caret. And on most keyboards, it's Shift-6. If you've got a letter here, this thing floats up really high. Sometimes it's used as a power operator in some computer math operations, but it's not necessarily so. What this caret class does is it's like a flag. It signals that inside this character class, all the characters that follow are the ones that's not in this character class. Now, you can only use it at the beginning. But when you do this, this would basically be the character class of all the not vowels. And so here we get our vowel stripped match of RoboCop eats baby food. Baby food! And you'll notice that it's even matching on things like the spaces in between the letters and the periods. But it is not matching on any of the vowels. Okay. So caret and $ characters are special. We talked about how they were special when they're inside a character class, or at least the caret sign is. Outside a character class, unfortunately, the regex language used them in a completely different way. Really nice languages don't always reuse these symbols, but we saw that the question mark got reused to talk about greedy and non-greedy matching. Unfortunately, the caret is going to get reused also. So if caret is not that first character inside a hand-constructed character class, it means the beginning of the string. And so hello will gladly match hello. It would not begin at the beginning of the string. The $ character is very similar, except the $ character anchors your match to the end of the string. So right here, this is some digit right before the end. So if your number is 42, then that matches 2. Whereas if they had typed in 42 is your number, it would not match it because the word number is not does not end with a digit at the end of the string. Instead, they decided to come up with an example where they just changed it to words. But the point is that even if there was a digit in this string, like your number, comma, 42, is a good number, then you might be able to match a digit. But there's no way you could match the pattern because the digit is the digit right before the end of the string. All right.
Question. Can you scroll back up for a second? So say for instance, where it says your number is 42 and it's the numeric 42.
Right.
If I would have put a period right there after the 42, would it have matched?
It would not match because period would be the character at the end of the string. Very good observation. So now we can use this newly found caret and $ symbol, and we can match this of down here and there. You'll get by if you just remember how to use them. So the wildcard characters. Sometimes you want to match a character, but you don't really care what character it is. Maybe it's just a spacing between something. But you need to count them. You need to make sure that you match exactly one off. All right? That is where the period comes in. The period is any character in the regular expression language. So this match of period at will match cat, hat, sat, lat, and mat. Because what will happen is there's some character before an AT here, and that some character happens to be C. There's some character before the AT here, and that character happens to be H. Likewise, it happens to be S. There's some character before this AT which happens to be L. And there's some character before this AT which happens to be M. So notice that here the match was not a whole word. It was just a couple of characters in the middle of a word. The character was that they use inside the question mark. It's about star. And this is the regular expression that says first name colon. Now remember, none of these characters are special characters. None of them are in a character class, so it's actually going to match each one. And then it will capture something. And then it will look for a space afterwards and last name in a space, and then it will capture whatever that is. So if you said first name Al Latter, name Al John Swagger, as much as possible, which would include the space and the John afterwards, but it does need to reserve one space to continue the pattern right before last name. So here the group 1 is Al and the group 2 is Swaggart. So the dot star, we talked about greediness. All right. Likewise, you can not greedily match. So when you not greedily match, the smallest possible match would be what? The smallest possible match of 0 or more characters would be what? Because if you wanted to say not overmatch, just match the minimum first name, then you would actually have the pattern fail to match with 0 characters. And so you would try matching it with 1 and try matching it with 2 and keep building that space wider and wider until finally it matched. It's sort of a slower way, but it gives you the smallest possible match. Okay, so here we are. Remember that greater than and less than signs are not part of the regex language. The square brackets are, the parentheses are. The greater than and less than signs, they're just regular characters. So here we are matching the smallest possible characters between greater than and less than signs. So in the string to serve men for dinner, marked up in this way, since we're specifying the smallest possible match that makes this pattern work, it will grow to capture this to serve man. But it will not, due to the question mark making it non-greedy, grow to serve men for dinner. What a shame. So here's the group, and likewise if we take off the non-greedy designator on this match, then the group is to serve men for dinner, the whole string. So I know we covered greedy and non-greedy matching before. In conjunction with the dot star operator, is there anybody who doesn't understand it? Good, because the patterns, once you do get a feel for regex, the patterns keep coming back again and again. So now we've got a question. What if our string actually contains a new line character? And if it contains a new line character, then we start wondering about what does that $sign mean? Does that $sign mean up to the new line? Or does it mean the actual end of the string, which might contain many new lines in it? Fortunately, the regex engine allows us to configure our compilation to decide when we compile the pattern. So this RE comes from the module we imported, and the .all is a special flag that's in there that basically says when we compile this, we are going to allow the dot to match new lines. Okay? And so serve public trust dot star to match that entire string, new lines and all. All right? If we did not have that dot star, then it would not allow the dot character to match new lines, and we would simply get serve the public trust. So now it's time for a recap. All the special characters. Question mark is challenge response, people. Question mark is
0 or 1.
0 or 1. Awesome. Star is
0 or 1.
plus is curly brace number, curly brace is
Whatever the number is.
bingo. Curly brace number, comma,
At least that many.
at least that many. That number or more. Awesome. I heard both of them. That was great. Curly brace number, comma, number, curly brace. The range between, bingo. All right. And they didn't put it in there We'll just cover it for completeness. Curly brace comma number.
Actually, it's a line above.
Yeah.
Oh, is it?
Yeah.
Boy, I was really trying to blow through these. I blew straight past that one. Okay.
At most, yeah.
0 or more. All right. A range with a question mark after it.
Non-greedy.
Non-hungry. Non-greedy. Sorry. I had lunch on my mind. Non-greedy. A star with a question mark on the end. Zero or more, non-greedy. A plus with a question mark at the end. One or more, non-greedy. Carrot spam. It is Python. You'll get plenty of spam references. Matter of fact, some would say that you would get spam references along with spam, spam, and more spam. But, go ahead.
Oh no, sorry.
You were stretching. That means that you answered it. Carrot spam. What does that mean?
Starts with spam.
Beautiful. Spam dollar. Ends with spam. Dot. Wild card. How many characters does it match? One. Now, you can configure it to match new line characters. Okay? But by default, it won't match new lines. Backslash D. Backslash W. Backslash S. White space. It's more than just spaces, but you're right. Backslash capital D. Not digits. Perfect. Backslash capital W. Beautiful. Backslash capital S. Not white space. Oh, square bracket, sum up, ABC, close square bracket.
Either A, B, or C.
A, B, or C. Yes, very good. Same thing with a little caret at the beginning. Not A, B, or C. All right. Now, we had talked a little bit about how we could configure this compile to allow dot to match new line characters. All right? There are other ways in which we can configure the compile. Sometimes it's really inconvenient to compile Robocop with a capital R, proper name, Robocop, as if somebody's shouting on IRC, Robocop, as if somebody's using leet speak most annoyingly on IRC, or Robocop, as in somebody just freaking doesn't know how not to use their shift key. If we wanted to have all combinations of upper or lowercase Robocop, there's a couple of techniques we could use. One, before we use the input, we could just simply say this input to lower, capture whatever that is, and then match. But, there's got to be more than one way to do it because that might not be the way you wanted to express yourself that day. So, you can use, again, it's a value inside the regular expression, the RE namespace that we got from importing RE, ignore case, which also has, because apparently ignore case is too much typing, the shortened version of REI, not to be confused with a sporting goods store. So this is Robocop, REI, and it will match. It will include these patterns and all of the other case combination patterns you could possibly think of. And it will do a case-insensitive match. So it will match this Robocop, it will match that Robocop, it'll match that Robocop, and it'll match really annoying Robocop up there. So who is unclear about the concept of passing these flags into the compile? Because that's one thing that they don't cover very much. They're covering it on a case-by-case basis. if you see a compile with a comma and something after it, what do you think that something after it's going to be? It's going to be some sort of configuration that alters this pattern. REI, RE ignore case, RE, was it dot all? These are going to change the behavior of the language. And so whenever you see this pattern here, you can leverage this pattern to write a less complicated regular expression language in here. Because otherwise I would have to have written something that looked sort of like this. And so on for each character. All right. Substituting strings. So, that regex object has a convenience method. And the convenience method will basically take the match that you have configured inside your regular expression engine and replace it with a substituted string. So agent followed by a space and some word character, of which there has to be more than one word character, will be replaced by censored. So this would be the classified version of the document that's not ready for public release. Agent Alice gave the secret documents to Agent Bob, thereby exposing Alice and Bob and making them targets. Inside our redacted document, using our regex sub, we would get censored gave the secret documents to censored because it would match. Remember, this match is going to match the agent word too. And so you would get this agent Alice is the match, and it's replaced by the word censored. Okay? So sub is kind of a nice little routine that will take your regex and whatever pattern you've got in there, substitute a string. You still have to compile the regex to get the regex object, but you can then call the sub and replace the matches with some sort of constant string. And if you want to remove them altogether, you would pass in the string that is quote quote. All right. So when you want to use this sub such that you basically substitute based off of grouping, you can type \1 or / whatever your group number is and control which group the substitution applies to. For example, this regular expression down here, which is agent, has to have at least one word character and then possibly others. Here we can basically redact it and say that we're going to pass in the first group and then the rest stars. So this is our first group. This will match the first character of the agent's name. And then the rest of it's outside of our grouping expression. So if we printed, as we did up higher, if we printed the match, if we printed the group 1, then that match would return back the first character of our redacted agent's name. So if we said this and then we just did a regular match and then grabbed that object and printed out group 1, then that would be A, because the agent space is not part of the group. The A would be that first word character, and then these would be this W star portion of the match. We're not going to do that. We're going to show off the sub command. And so we're going to basically say substitute. I want the actual value of the first group and then a bunch of stars. Remember, this portion right here is not a regular expression. It's the substitution string. So now it would say A told C that E knew B was a double agent and make it slightly easier for a person to read this redacted document and understand that there are multiple people here as possibly opposed to the same person referred to multiple times. So when you're managing a complex regex, it's real easy when your patterns start off small, and you should build them small and use them to compose larger and larger patterns. All right? But as they get patterns, you can basically get to a situation where you get some really big, long, hairy regexes. Okay? And when you get these really big, hairy, long regexes, there are some extra ways in which you can make these regexes easier to understand. Okay? Python uses this verbose flag, which comes in as the second argument to regex compile. This is one of those regular expression control variables, the ones that we use to alter what compile does. And what this verbose will do is white space, such as the new line here, and the white spaces here, are ignored. Anything that comes after a hash sign, as Python normally uses for comments, is also ignored. So this allows us to take this regular expression, which in the regular expression language, all is one line, because spaces would actually be turned into real matching spaces, and allows us to write it in such a way that we can comment sections of the regular expression. So it's easier for us to track which group is for what. And so this would be the area code group, possibly with parentheses. This would be a separator, the first 3 digits, a separator, the last 4 digits, and this would be a special expression that possibly can match extensions, which, as we see here, is optional because not all phone numbers have extensions. Remember that when we decide that we want one string that's going to cover multiple lines, we use the quote, quote, quote operator to open the string and the quote, quote, quote operator to end the string. This is still one string. But this flag here is going to instruct the regular expression engine when it's compiling this to ignore the white space and the things that look like comments. Okay? Is anybody unclear on that? Nope? All right. Doing this, when you start coming up with really big regular expressions, big enough that you feel you need to write notes to keep track of where you were, you now have a technique that allows you to do it. What happens if you want more than one directive to the compiler at the same time? Well, it just turns out that these directives can be combined. Now they're combined with an operator, which is the Python OR operator, because these are actually numbers. They're like bit masks. So when you see this, it's going to construct a new value that effectively means ignore case and .all. So this portion, being inside the parentheses, will get evaluated first, coming up with some new unnamed flag that happens to include ignoring case and the dot matches new lines. Okay? And if we needed to have more than just those two, we decided that we were going to do that verbose notation we just covered, the .all and the ignore case. You just simply use more of these pipe symbols and combine all the flags you want together. You'll still just be passing them into the flag parameter. There's only one flag parameter. This does not pass 3 things in. It takes these 3 things, combines them into some sort of compound directive to the flag parameter, and then passes that compound directive in. And then this way we can compile foo, and it will match uppercase, lowercase, and all whatever mixed cases. If there was some sort of thing inside the string that included a new line, it will continue matching past the new line. And even though we didn't put foo in the triple quotes and put extra new lines in it and extra comments in it, it will instruct the compiler that if it finds white space in there or comment looking like things in there, just ignore them. Okay. So now we have just covered pretty much everything that is instructive about regular expressions. It's time for examples. And the example that they have here is they want a phone number and email address extractor. Now, you've probably seen enough phone numbers this evening in order to last you for a while. So we'll gloss over some of the phone number parts, but the idea is that this program will grab text off the clipboard and find all the phone numbers and email addresses. Now, again, to answer your question at the beginning of the class, it's not going to find valid email addresses or valid phone numbers. It's just going to find stuff that looks like phone numbers and email addresses. And then it'll paste them to the clipboard. So Paperclip, which is close to Paperclip, is a module that you would import in order to have access to the clipboard. So you could copy and paste the strings back and forth. You want to find all matches, so big surprise, your pattern is going to use what? Once you compile your regular expression pattern and you have the regex object, what method will you probably call on it to find all matches? Find all. Awesome. Okay, blah, blah, blah. We'll skip over a little bit here. Here's our pattern for phone numbers that we've already seen before. Okay, we need an email regex. We need to find the clipboard and find the matches in the clipboard and copy the results back to the clipboard. So we need a regex for the email. This is a very complicated looking regex, but basically these are all the characters that are allowed to be in an email username. The plus indicates one or more. There's the @ sign, which is not allowed to be in the user email name because it separates the name from the domain name. These are all the characters that are allowed to be in the domain name, and domain names are allowed to have dotted extensions on them. So you can have basically, at Yahoo or at yahoo.com or at, some place that has a couple of them. But there's only so many of these extensions that are allowed in a valid email address. And because we decided to document it out with nice little commentary, we used the verbose flag on the compiler. So it won't actually try to match hash username. All right, so now we've got a pattern for the email addresses. Now it's time to actually use that paperclip. So we're going to capture the text inside the cut and paste buffer. We'll find all, okay, using our compiled regex, and then we are going to basically say, hey, the phone number is going to be all the groups, stripping out all of those little, formatting characters like the parentheses and whatnot. Okay, and basically, if there's an extension, then we'll add an X along with the extension group. Then we're also going to try to find all the email addresses, and the email addresses, apparently we're only concerned with the first group, which the first group happens to include all of the email. Then it's time to learn how to use the paperclip. And so basically here we're going to copy back in to the to the cut and paste, into the copy paste buffer all of our matches joined together with new lines. So that means we'll get a bunch of text with new lines in between, and then we will, of course, copy that back to the clipboard. So when we run it, this will be the contents of the clipboard, assuming that we actually had text in the clipboard that looked, like text that included those emails and phone numbers. And I wanted to go breeze through it real fast, just giving a high-level overview, because the actual details are better understood by you attempting to type this in and work your way through the logic inside a Python machine. Because then that way you can actually change it, mess with it, play with it, break it, and breaking things is a great first step in learning how they really work. So that covers regular expressions. I've got a minute or two. Does anybody have any questions about regular expressions? This is the time that you ask anything you want about regular expressions. Yes?
If you wanted some that apply to other languages, like different...
French or Japanese happen to be accent, or the characters that represent specific. Was afraid to ask. Yes? Good question. Fortunately, possible. So, when there is a means non-greedy matching, okay, when this construct is a group or a single character, so basically it's not ambiguous, okay, and that may be a horrible way to differentiate and reuse. This was pretty common practice, and so that's just how it is today. And that's just part of its language. Also, a lot of these constructs didn't exist back then. For example, dot existed and star existed, but niceties like plus, you would have literally written the pattern and then written the pattern again with a star. And question mark, you would have made a group where you matched nothing or matched the pattern. Okay, so not all regular expression languages, even though they are all regular expression languages, are the same. If you change a programming language or use a command line regular expression matcher like regex, then it may be useful for you to review to see what special control characters it permits and which ones it doesn't. Most of them are consistent amongst the languages, but many of them are just missing. Usually you'll have problems with missing as opposed for them meaning something different. Okay, any other questions? No? Fantastic, that's regexes. Go out there and match something. Or substitute something, there you go.